Namaste. Here in this video I am going to explain JK flip-flop, T flip-flop and D flip-flop. First let us see the JK flip-flop. This is the circuit diagram of JK flip-flop and this is the circuit diagram of D flip-flop. First I will show the truth table of the JK flip-flop. You can observe the truth table here. Suppose if a clock is a negative edge triggered clock or falling edge of the clock, what happens you can observe. And here if whatever may be the clock, that is if you are here we are considering the negative clock, here negative pulse clock we are taking. Here we are not going to consider this, so that's why they have written like this in the truth table. Suppose the preset and clear are 0, 1. These are the two inputs. We act as inputs. J and K also act as input. J and K flip-flop. So here whatever may be the value of J and K, it will not going to change. It is 1 and 0. So preset is 1 and clear is 0. If you make it as clear as 0, clear bar it is. So obviously if you give it as 1, what happens means it will clear it. So suppose Q is 0, Q bar will be 1 obviously. And suppose if you give it as 0, 0, it will not take. Preset is also 0, clear is also, if you make it as 0, it will not. It is called indeterminate state. Next, the actual operation of the JK flip-flop, from here it goes. See, falling edge of the clock, and suppose if you make preset is 1 as well as clear is 1, if both J and K are 0, 0, it has to retain the previous state, that is 0, Q bar. Suppose if the previous state is 0, 1, it will retain that 0, 1. Suppose if the previous state was 1, 0, it will retain that 1, 0. And next you just see, observe, both preset and clear both will be high. So what you should do is, first actually you should make it both as 0, 0, then you have to make both preset and clear as high in the circuit diagram. Then so you have to give the inputs like that, and you have to change JK only. So next combination is 0, 1. Suppose if you make J as 0, K as 1, the output will be 0, 1. That is, so it will set. It will reset actually, sorry, it is resetting. Suppose if you make J as 0 and K as 1, what it will do is your output will be 0, 1, that is it will reset. And if you see JK 1, J is 1, K is 0, so what happens means it will make 1, 0, that is it will be set, and at the end 1, 1. If both J and K both are 1, what will happen is it will toggle the previous state output. Previous state output, suppose if the previous state was 1, 0, the current state will be, current state output will be 0, 1. Suppose if the previous state is 0, 1, now it will make it as 1, 0. So here this is the circuit diagram of this. So you can see the feedback from the Q. We have given the feedback to the this one input side, whereas here also from the Q bar also we have taken the feedback and we have given it fed to the J side. So you can observe J and K are the inputs, and clock is given. This is the master slave JK flip-flop. So clock is given for both the this one circuits. We have the common clock, that is a synchronous pulse we are going to give it. So preset and clear, how I have shown in the truth table, like that we have to change. After making the connection, you have to change the inputs according to the truth table, so you can observe the output here. Next is JK is over. Next we are going for D. The same circuit diagram we are going to take. Using the same circuit diagram, small change we have to do here. What change we have done here is, in the JK we have separately we have given two inputs, whereas in D we are going to short J and K inputs. Along with that, between J and K we need to put one inverter, that is inverter. Here we have used the NAND gate as the inverter itself. We have shorted the inputs of the NAND gate and we have given it to this, and you can give, see, suppose if I give D as 1, so suppose if clock is high, operation is proper, clock is high in the sense we have taken here falling edge. So in the falling edge of the pulse, what happens means if you make D as high, the output will be high only. If you make D as low, so what happens means the output will also be low, that is in the D flip-flop. Whereas one more is there, that is a T flip-flop. In T flip-flop, what happens means, what we have to do is, instead of, see here itself, in this diagram itself I will explain, instead of putting this inverter, instead of putting the inverter directly, we have to short this J and K inputs. Suppose if I short directly as it is, if this, and if I give 1 here, what happens is JK, so 1, 1 we are going to give, 1, 1 if I give it, what should happen to Q bar? It has to toggle. So if the previous state was 0 idre, suppose it will make it as 1, and suppose if the previous state 1 idre, what it will do is it will change it to 0, 1. So suppose if I make it as 0, T is 0. Suppose if I make T is 0, what happens means here the output will be retained. The previous state output will be retained, and the same output will be there for the same state. That is, suppose if you make T as 0. That is what T is nothing but a toggle state. Thank you.